Perfect. And then when you're done, later on here, I'll have you email me the link to that recording, and I'll send that to the media folks. I don't know if you've noticed on the Ezra Facebook page, some of these reviews have been going on there, so you might find yourself famous on the Ezra page. So I guess
We actually looked at a couple just to see what
yeah. I mean,
what's
they're
going
being
on.
done by different people, and I'm sure
Yeah.
different people have different priorities and stuff. But first, I want to really emphasize this isn't judged. You're not gaining or losing points tonight. This is merely a safety review, and wanting to make sure that that you are making considerable progress towards having a flight-worthy rocket next month. What we're trying to avoid are situations where we have teams gluing fins on rockets in the parking lot of the hotel the night before the competition, and things along that line. So I want you to.
We haven't ever been in that
Yeah,
bad of a situation.
yeah. Well,
Maybe
you
pretty
would
close
believe.
last
Yeah.
year, but
Okay. Right. But anyhow, I mean, it's not. Uh, you're not being judged, as what I wanted to point out. So show the rockets, and maybe we can do some introductions. I'm Bill Diesel, and I'm the Director of Environmental Health and Safety at Iowa State University, a bit south and west of you guys. And I'm also the one of 3 advisors to the Cyclone rocketry team here at Iowa State University. But I have absolutely no judging capacity with my own team, so don't worry about that. They don't get an edge that I'm associated with Ezra. Bram, do you want to introduce yourself?
Sure, yeah, I'm Bram Soltis, one of the judges this year for IREC. I'm currently a propulsion engineer at Ursa Major Technologies. Yeah, so I'm not judging you guys, so don't worry about that either.
All right, fantastic. And do you want to introduce folks on your side for us?
sure. So I'm Noah. I just graduated mechanical engineering. I'm the technical
Congratulations.
officer for the team. And so we have starting on this side.
I'm Carter. I'm third year mechanical engineering, and I'm the payload lead for the team.
Okay.
I'm Kenan. I'm fourth year computer science. I'm next year's avionics lead.
Of course.
And
Yeah.
on this side,
Second year physics, and I'm next year's vice president.
this is
Fantastic.
Melanie. He does have a
Yeah.
name.
Okay.
So yeah, as I said, could we have a short presentation? It's not too long, just to give you a brief overview of what
Absolutely.
the rocket
Yep.
is. And then we have the rocket right behind the computer. You can't see it right now, but as assembled as it is right now. And you can
Fantastic.
take a look at that. That's why you see 2 of me on the call, because the other one's my phone, so we can do that. Okay, so let's share screen. And oh my gosh, I can't hit the present button anymore. Can you see this? Yeah.
Yeah.
So our rocket's called CALAMARI. It's like a long acronym. I think it's on the next slide. Yeah, it's kind of funny. Composite Lightweight Advanced Materials Atmospheric Rocket Initiative. We're in the 30K COTS category. We've entered this category now. This will be our 3rd time in this category. So we have a little bit of experience doing this before to varying degrees of success. It's flying on an N3301 CTI 6-grain XL. The airframe is 4.5 inches ID. Kind of a little bit of a weird choice. A lot of people comment because it's not super common in rockets, but it just happens to be the size of the aluminum mandrels that someone on our team got before my time. And it kind of works out for us. So the design philosophy is kind of pseudo min diameter because the tubes is only very slightly bigger than the
Darn close, anyhow. Yeah.
So
yeah.
like effectively, like the design is very similar to what you might see on a minimum diameter in terms of retention and stuff like that. Recovery, very simple, like high power rocketry style with dual separation, dual deploy. So drogue between the motor and the av bay, and then main up above between the nose cone and the av bay. So we've had, like, in the past, we've done more complicated single break stuff with tender descenders, and the reliability has just been really bad. So trying to keep it simple here. So here's the flight predictions. 34,300, Mach 1.9, about just under 15 Gs. I don't know if you've are you one of the ones who sees our reports I think you
Yes,
gave us
yep,
feedback.
mhm.
I don't know if so. I don't
I
know if
have
you've seen
not.
our most recent one yet, but that obviously would have a lot more detail on these sims and stuff like that. But these are kind of the key numbers. But pretty much as you'd expect for a 30K category machine.
Right.
All our tubes, we do all our tubes ourselves. So the body tubes are made on a big aluminum mandrel, just using like carbon fiber fabric. We have done like a kind of a mixed laminate stack up on the carbon tubes, just because we have access to a couple different types of weaves. So that can help. It helps with the bending and the hoop stress and stuff to get some of these stack ups in there. The fiberglass, we only were able to get one type of fiberglass, so it's all just satin weave, but it is S-glass, so it's a strong fiberglass that we could get. The nose cone and the upper like main parachute bay are made of carbon fiber, and the motor section is made out of carbon fiber, and then of course we have a central section fiberglass for radio. So yeah, they're just sold on an aluminum mandrel with over some mylar sheet to help with pulling it off the mandrel at the end. But pretty standard way of doing tubes. Couplers are made the same way, just on 3D printed mandrels, so they're a little bit smaller, so they actually fit. Everything's like 1 cal where it needs to be, except the nose cone shorter because they let us do that. But we make sure everything's a nice tight fit, and as rigid as we can get. We also made these little alignment features with these little dowels, so everything only gets put together in the correct way. Hard to believe, but we have made that mistake in the past. So any little feature that can help that way is good. But all the couplers are basically made the same way as our tubes, and we can show you everything once we get there. Fins. Again, we made our own fins, so we make our own carbon plate. So these have 2 layers of unidirectional to help with like the fin bending, as well as 4 layers of plain weave just to stack up the thickness to what we need. Because we are not min diameter, we're pseudo min diameter, we get to actually do through the wall. We don't have to do surface mount. So they're not like bonded onto like an internal motor tube, but they are like filleted on the inside as well as on the outside. So we have structural air epoxy for these fillets. I think they turned out pretty nicely. And then we top it all off with tip to tip. So there's 2 layers of unidirectional under there, and then 1 layer of nice spread toe for like a nice finish. So FinSim tells us that they're good up to Mach 2.6, and that's like before taking into account the tip to tip, or even the fillet radius. So that's pretty good. And you're using for the inputs for FinSim, it's like use like the air epoxy data sheets. So we're pretty confident with that. Also, we used very similar fins last year that flew not quite as fast as going this time, but they handled the task just fine. Motor tension. We have this fancy machine part at the front. Threaded rod and the eye nut come onto this. There's a short gap just to make sure that the actual thrust goes through the rear thrust ring. So because we're not actually min diameter, we have this other piece that basically expands the thrust ring of the motor to our body tube. We've used this design at the back last year as well, worked pretty well. But this front one, we got some feedback on from the Launch Canada judges. So that's our other competition, to like leave a little bit of a gap just to make sure that all the thrust loads are going through the back. And also in case we get any thermal expansion, like it won't push out the back, which could then maybe like push the forward closure down into the motor and like, cause one of the O-rings to stop sealing or something like that. And of course, that's all going to be secured with thread locker and like some wire to prevent the eye nut from unscrewing during recovery, because this is like the main attachment for the drogue. So it's in a coupler, zipperless style. And then this is both permanently epoxy bonded in as well as screwed in as well. So what do we have next? We have recovery. Mel, do you want to talk about recovery?
All right.
Okay.
So we kind of mentioned already, but our rocket this year is using a dual bay deployment recovery system. So we've got our drogue first is a 24-inch elliptical fruity shoots, which will take us down to 90 feet per second descent rate. And then their main chute will be deployed using a deployment bag and then a little pilot chute to get that pulled off. And that's a 96-inch IREC chute, which will take us to our landing rate of about 20 feet per second. We've got 35-foot shock cord in between each section, and it's Kevlar, so it's pretty strong. We've done our ejection testing, and we're using just black powder free floating charges for the deployment of each of those sections, and shear pins as well to keep that in place.
Yeah, so we're just we've tested basically all of that except our deployment bag. We're still waiting for that to arrive because we ordered that. We had an old one that doesn't really fit our chute properly. So Kenan, you want to talk about the avionics?
All right. So we're using
Can you hear Kenan by these guys all right,
Yeah.
even though they're a little farther away? Okay.
So we have COTS and SRAD systems for both an altimeter and a GPS board. For altimeters, we have an RRC3 and a custom SRAD altimeter. For GPS, we're using a featherweight and a custom SRAD GPS. We're also using custom screw switches.
They're pretty much exactly the same as any commercial one. We just
Yeah.
couldn't buy any, so we made them.
Much cheaper. We want to flight test both SRAD boards on the 27th and 28th of May.
Smaller, high power rockets.
Okay.
Yeah.
So we've got the hardware fully set up. We have the boards printed. They're just at a frame over there. Still working on the firmware for them. COTS have already been flown successfully in the past. If we can't get the SRAD board fully tested and nominal, we're going to be using a second RRC3. And we also have a tele GPS as a backup in case we can't get our GPS working.
So yeah, just expanding on that a little bit. Obviously we want to make sure our altimeter logic is like bang on because we don't want it to pop the chute on the way up. Because that's obviously very bad. So if we can't like have some really solid tests with that when we go, we only have there's hardly any like high power rocket clubs nearby us. So we only have like a couple chances to fly like other rockets. So, but one of them is like coming up. So we're going to bring some smaller rockets. We're doing some certification flights and stuff. We're going to bring our altimeters along with us, to hopefully, get some tests on that. We have tested our COTS GPS, our COTS tracker, and all this stuff, and we have backups. But and yeah, everything has its own battery and its own switch. Everything's fully independent. And finally, payload. Craig, you want to talk about the payload?
And yeah, so for the payload, we're doing a vibrational energy capture test on board rocket, also known as Vector. Essentially, it's just generating power from the vibrations caused from thrust oscillations in the rocket launch. And yeah, we also are using custom screw switches to activate the battery on the launch rail. And yeah.
So yeah, that's the payload. It's pretty neat. It's up in the nose cone, but I guess the payload, what goes on inside the payload isn't really of your concern, making sure a rocket's gonna crash or not. So that's it for a presentation. You guys have any immediate concerns, or should we just go start showing you the rocket?
One question real quick. You guys said the kind of your ab bay section where your GPS will be located is made of fiberglass for RF transparency.
Yeah.
Cool.
The last year at the event, we had 3 rockets discharge their powder loads on the pad. And yeah, that was remarkable. And what was more remarkable is I actually was standing next to, so maybe it was just that I was really bad luck or something like that. But I actually witnessed all 3 of those discharges. And we never totally dialed that in. I think there was some speculation that those were SRAD altimeters that students worked on. So just putting that as a comment that some very bad things can happen on the way up, but we actually had some very bad things happen right on the pad. And so I don't know what color you're using for the finish of your rocket, but this year, because all the solid rockets are going to be kind of in one area, rockets could sit on the stand for quite a while before that rocket goes up. So there'll be a lot of New Mexico sun beating down on them, and those rockets could get hot. So just throwing that out there with your
We actually
SRAD.
have like basically a team rule that says all rockets have to be white for that exact reason.
Okay,
So-
yeah, white is my favorite spaceport color, actually. Yeah, so fantastic. I appreciate that. So yeah, okay. So yeah, if you want to start showing us your rocket, we like looking at rockets.
Okay, can we see this? Okay, so this is currently there's the back, there's the middle, there's the front. There's no nose cone on it. We're not quite done making the finalizing the nose cone. Mel, you can show us there's still like a 3D printed mold inside that, and obviously we haven't attached the tip and sanded it down and stuff like that. So we have if you want to see it looking together, we have an old nose cone that we have put on for ejection tests and stuff like that. But yeah, that's basically the one thing we're still waiting on.
Did I hear in your presentation that the shoulder on the nose cone is 1/2 caliber?
That's what the rules state it can be.
Yeah,
so
yeah.
that's
I'm not arguing with that. I just confirming that. Yep.
Yeah, it is.
Okay.
Yeah.
Okay.
It's actually slightly better than 1/2 caliber. I think
Okay.
it's like 0.6 or
It's
so.
a long half.
If we find it's gonna be if we test it and it's loose, we can make another one that's longer.
Okay.
Yeah. Anyways, where do you want to start?
Maybe the motor. Start at the bottom.
Okay.
Work way to the top.
Do you want to take it apart here?
Can you grab this?
Yeah. 1 second. Yeah. I'm gonna mute the computer and switch the audio to the phone. So hold on a second. Okay, can you guys hear that?
Yep.
Okay, getting some echo.
But I need to
maybe you
go.
muted it. Okay.
Okay, can you guys say something to make sure I can still hear you here?
Yeah. Can you hear us?
Yeah, very quietly. Say something again.
Test.
Yeah, okay, that's good. That's good.
Okay, fantastic.
Okay, here at the back. Here's the fins. They got tip to tip, really sturdy. This is the rear retainer. The one thing we forgot, I didn't mention in the PowerPoint, is we initially planned on just some centering rings on the inside to help aligning the motor when we're assembling it. We replaced that with just a short section of cardboard 4-inch tube that just fits in the middle. So this is completely non-structural. It just helps us align the motor when we're assembling it.
So how does that retain the motor then?
So this effectively, you see the lip here, the thrust spring of the motor goes against that, and that prevents it from moving forward. It's prevented from moving backwards from the top.
Oh, okay, because it's actually you're screwing it into that peg that we saw in the diagram.
Yeah. So that there's a threaded rod there. It's not attached right now, but you can see the top here. There's a piece of tape on that. There's a hole there. The forward closure will have a section of rod in that'll stick out here, and that'll get attached with the eye nut.
Yep. Okay. All right. Yeah. So I have seen that done on a few. Actually, I've seen it on Canadian rockets. Maybe that's a Canadian thing. So where they're using. Yeah.
I feel like it's a decent 30K COTS is definitely the most popular Canadian category because you're not allowed to do SRAD solid up here. So yeah. Anyways, if you wanted to see a rigid couplers, obviously there's a metal bit epoxied into here, so this is super sturdy.
Yeah. And it looks like you've obviously read the rules. You know that you need an entire caliber for your couplers. Yep.
Everything else, like this is a full caliber, and the avionics bay, which I guess we can show you next, is like a little bit more than one caliber.
Okay.
It's like, 1 point something or other. Should we show the avionics bay, or why don't you?
Absolutely.
No matter, body tube is rigid. Just squeeze the body tube and. Yeah.
Thank you for showing that. That's actually something that I do in safety
Well,
reviews.
we saw that in I saw your email asking us about that. So
Okay. All right.
So let's take off this one. We can move this out of the way now, this back part. Unless you wanted to see more of the fins, but hold on. Yeah, so there's a body tube. This is the avionics bay and its coupler. There's like a switch band on there that doesn't have holes in it yet for the switches, but and then there are bulkheads on either end. These are stepped, and this bottom one has holes in it to screw on this other section of fiberglass tube. This part, these will stay together during the flight. It'll separate just above the motor. Shall we open it up? Okay, and let's take this. Just pull. So this is like a prototype of the ad bay. Obviously, where it's going to get reprinted, and there's not really much on it right now. But altimeters are kind of going down here. There'll be more stuff over here. Switches and cameras are on this middle section, and then batteries are up in here. But it's pretty standard, a couple of threaded rods into a bulkhead, and then the wires come out and hook into these lever connectors. So we only have to like plug in the E-matches into this. We don't have to plug the E-matches like all the way down into the altimeters directly. So like theoretically, we can assemble this whole thing like the day before the flight, and we never have to open it up like once we get to the desert, because we can just turn it on with the screw switches and plug the E-matches into the end of the bulkheads. So one of our big goals of this year is like making the assembly process easier, because we've had some pretty bad designs in that regard in the past. But yeah, any comments on the av bay or coupler or anything like that?
Looks great. Is the are your trackers going in there too, or are they going to be in another location?
Yeah, no, trackers are going in there too, and they're like,
Okay.
That's why I went down this one half.
All right. Okay.
That's gonna be
so you're gonna use one of those screw switches for your trackers too, because you're talking about being able to button it up the night before, and
yeah, the trackers are on screw switches as well.
Okay. All right.
Yeah, one of the like design features we had for this year is everything that is electrical should be able to be turned on at the pad in case there's like a long wait.
Yep. Okay. Just stating the obvious. So the featherweight tracker has an on-off switch on it, so make sure that switch is on. Yes, because otherwise that switch. Yeah.
We'll definitely make sure that. I think you can also. Can you confirm, Ken? Can you like? I think I talked to you about this before. You can like solder on like a different switch onto, like onto the featherweight or something like that. Like it has that ability. So yeah, and we have tested, like we've put all these tubes together and put the tracker in there and confirmed that we can still like get a lock and everything like that.
Perfect.
So anyways, here's the upper body tube. There's not much in there. You can give it a squeeze again. It's very sturdy. And then this is the coupler that we're going to use for the nose cone. The nose cone it's not attached to anything, but it's a nice tight fit in there as well. Did you want to see anything else? These are actually our SRAD boards.
Nice.
Not that that's like critically important. And then like there's like that, there's nose cone over there as well. Unless you wanted to show the payload, if there's any structural concerns about the payload.
Yeah, it's in a disassembled state right now. But, it would look like this. It would have a stainless steel tube around it to kind of block the magnetic field. We have PCB for it, and that'll be turned on with the screw switches. And then our battery for it will be mounted between two plates with the 3D printed holster to minimize stress concentration.
Keep in mind when you get out to the pad, that, I mean, your payload, if you're using screw switches to turn that on, make sure that the pad manager is okay with it, but you might want to turn on your payload while it's still horizontal, or it's going to be way up in the sky. And it's going to be hard to get to turn those switches on.
Yeah.
Sounds good.
Yeah, we'll definitely have to double check that we're good to do that. I mean, we should be. There's no way we could accidentally turn on any charges up on the nose cone because it's very separate.
Right. Yeah. But also be mindful of where those switches are. I've seen some students accidentally, they just didn't plan it all out, and it turned out that the hole where their screw switches are, or where the magnet was for their magnet switches, was right where the rail is.
Yeah.
So just plan that all out. Yeah.
Ask us why we put those little dowel alignment keys.
Okay. All right.
Maybe don't, but
wisdom comes from experience.
Yeah. We scrubbed our launch like 3 times at Launch Canada last year for various reasons.
Okay.
But yeah, we're trying to get off the rail successfully for the first time. This time at Spaceport. Anything else that we have to show you? I guess the one thing you didn't see here, because it's not assembled yet, is like the recovery attachment point on the back of the nose cone. But that's basically like, there's another bulkhead. Do you know where that is, Mel? That's over there. That's from last year. Anyways. Yeah, so like this, just another bulkhead. This gets screwed into that coupler, and the rods for the payload come in 2 of those holes, and then the other holes, there's like a big honking U-bolt that the Kevlar attaches to. So we have some like big, like 2,000-pound quick links or something that everything hooks up with. That's pretty much it. Unless you guys have more questions.
No, I mean, your bulkheads are aluminum, so that, I think in the note that I told you that I like to have a big washer behind the eye bolts, but you probably don't need a big one because you have this solid aluminum.
Yeah.
Maybe a locking washer though, to keep those nuts where they're supposed to be.
Yeah, all the nuts that we're gonna use we're gonna use like nylock nuts.
Okay.
For everything. Right, like not every single one, but every like recovery related one. And the ones like holding the ab bay closed and stuff like that. I don't know if all the ones like on the inside of the payload are gonna be nylock, but
The outside ones will be nylock.
Yeah.
Yeah.
So that's like, we've been asked like specifically to do that by judges all the time. So
okay. Yeah.
Yeah.
Well, I mean, that's a place where there's a lot of failures, right? Where the parachute goes this way and the rocket goes the other, and then we have something ballistic on the field. So that's a super critical failure point, and that's why they give you such a hard time in the safety reviews.
Okay. Yeah. Anything else from us?
I just had one
Quick, but yeah.
comment. Yeah.
I'm gonna go back to the computer.
Yeah. Yeah, I think I saw with your e-matches, you have 2 connections. I assume you have 2 different 2 sets of black powder connections, or 2 sets of black powder pods.
Yeah.
Are you doing one with a little bit more powder just in case to compensate for the higher altitude in case of incomplete combustion?
Yeah, so the backup will be like a gram more than the primary, just in case the primary wasn't enough. I don't know.
Okay. And at that altitude, it's becomes very important that your powder is tightly packed. So
yeah.
Okay.
So they're like free floating charges in like little paper tubes.
Right. Yeah, but it's packed in the paper tube. Right? It's okay it's okay that the tube's floating around in there. That's just fine. Yeah. Okay. And did you do ground testing of those charges?
Yeah.
Okay.
Yeah, we did ejection tests like last week.
Okay. Fantastic.
Yeah.
Gee, Go
think
ahead,
that
Bram.
was most of it. Yeah, I think the last thing I just forgot. How long is your shot board?
35 feet, like for each section. Yeah.
Recovery harness. Sorry.
Yep.
Yeah.
Yeah.
Shot cord is fine.
We all knew what you meant. Yeah.
Yes.
So yeah,
Sorry.
we interchange those terms all the time. So no, not a problem. So yeah, well, it's a good looking rocket. You know, I personally, I appreciate that you're taking time to not just put this thing together, but to put some real craftsmanship in there. And for those fins, I hope you put like a shiny urethane on them or something, you know, some kind of epoxy coating so we can see that the beautiful work that you have on your tip to tip, you know. So
yeah, I mean, it's probably getting painted up.
okay,
but,
all right. I have
No.
seen I have seen people put a really, you know, a clear coat on it and buff it
Yeah.
out and
it probably looks better on the phone camera than it does in real life. It's a little rough here.
okay, all right, yeah, no, I appreciate that. You had a very nice PowerPoint presentation. It was logical, made it easy for us to just look through there and have some confidence in it. And while your rocket probably isn't ready to fly tonight, you're getting real close, and there is still plenty of time before the event. So
Yeah, it's pretty much just a nose cone that we're waiting on, and some electronics like firmware for the
Okay.
SRAD. But like the COT stuff is all good. We could fly with we have like 3 RRC3s if we need.
Okay.
Not that we need 3, but
Yeah. All right. Yeah. Well, I hope you can
Great.
use your SRED stuff. That would be kind of neat. I appreciate you were candid about learning from mistakes. You know, as far as, you know, there's nothing worse than getting all the way out to the pad and having it on the rail and have to take it back off of there and you know, and walk back. So I'm glad to hear the learning curve isn't flat. So, but yeah, I've got what I need. I don't, Bram, if you had any other things you wanted to check. Okay.
Looks
So
great.
yeah. So when we're finished here, you can press the stop on that record and get that link to me. But congratulations, that's a great looking rocket, and I can't wait to see it fly.
thanks a lot for your guys' help.
Yep.
Yep.